I just want to do a quick video on integration by parts because I don't have one up there. So integration by parts is an integration technique that generally if I'm looking at a integral that has something times something, both involve a variable, so kind of like a product rule in when we're doing derivatives, my first thought is, can I get u substitution to take care of it? And if that doesn't work, then using my next thought is integration by parts. So the way integration by parts works is we have this little formula that says if you take an original integral that looks like this, you can find it by taking the u times the v minus the integral of v times the derivative of u. So what we need to do is look at this original thing and break it into a u and a dv. And generally what we want is, keeping this integral in mind, we want to keep that integral as, I guess, simple as possible. We want to be able to do that integral. So we look at this and we think, well, I know that x squared, when I take the derivative of it, goes down a power. In fact, if I take the derivative twice, I'll end up with just dx. So we would say that that would be a good candidate for u, because what I'm going to do is pick a u and then find du for this integral down here, and then I'm going to pick a dv and then find a v that goes with that for that v right there. So I want this and this combined to be as simple as possible. Okay, so if we let u be x squared, that would mean du is 2x dx. And that would mean that dv would have to be e to the 2x dx. Because, again, this integral has to be u dv. So let's check to make sure that's true. U takes care of the x squared, and dv takes care of the e to the 2x dx. So if dv is that, that means v would have to be 1/2 e to the 2x, because I just integrate that. The 1/2 is there to take care of the 2 that's kicked out by the chain rule. Like I said, then I'm ready to go down here and just fill in the parts. So u is x squared, and v is 1/2, I'll put that up front, e to the 2x minus. So then I have this integral of v, which is 1/2 times u du, but notice there's a 1/2 there and a 2 there, so they cancel each other out. And I'm left with just an x times e to the 2x dx. Okay, so notice we could say that this integral is a little bit nicer than that integral. And we feel like we're in the right direction, so we're just going to keep doing this. So I'll pick another u. This time I'm going to let u equal x, which means du is equal to dx. And I'll pick dv to be e to the 2x dx. That means v would have to be 1/2 e to the 2x. And we'll fill in the formula again. So this is going to be minus, and I'm going to put parentheses around it so I don't forget. U times v, that would be 1/2 x e to the 2x minus the integral of v du, which would be 1/2 e to the 2x dx. Okay, so that would be 1/2 x squared e to the 2x minus 1/2 x e to the 2x. Now this minus, with that minus, gives me a plus, and then I just have to integrate this. Well, this would have to be e to the 2x, and if I take the derivative of that, I'll kick out a 2, and I want a 1/2 there, so I'm going to have to put a 1/4 there, and then plus c. So there's a class example of integration by parts that's generally, if you have an e to the with a power combined, you're going to use integration by parts. Or if you have a power function and a sine or cosine, then you're going to use integration by parts. anything that has a product type with one of the factors of the product is something that you can integrate possibly over and over again without it getting more complicated. So that's a quick rundown of integration by parts.